to Naradar Academy. In this video, we are going to discuss about class equation. So this equation is particularly for writing class equation for symmetry group Sn. Okay, that is the permutation group is there, no? So how to write the class equation, that we are going to see in detail. Okay, right. So before going to class equation, let's define conjugate elements. See, if G is a group and AB are any two elements, then B is said to be conjugate of A if B can be written as C inverse AC. The C is an element of G. Okay. So if B equal to C inverse AC, then this A and B are said to be conjugate to each other. This conjugacy is there, no? This is a relation which is defined on the group, and this is an equivalence relation. Equivalence relation means what? It is reflexive, symmetric and transitive. So all the three properties are satisfied by this conjugate, that is conjugacy relation. So it forms an equivalence relation. Therefore it will form an equivalence classes. Equivalence classes means what? That is the union of the classes will give you the entire set G, and the intersection is empty, isn't it? Now the conjugate class is defined by C of A equal to set of all x in G such that x is a conjugate of A. So this is called conjugate class of A in G, right? So they form disjoint equivalence classes. Next one, let's define center of a group. The center of a group Z of G is nothing but the collection of all elements which commutes with every other element of the group G. Okay, right? Center is nothing but collection of all x in G for which Ax equal to xa for all A in G. That is every element of G which commutes with every other elements of G is called center. Okay. The center is a subgroup of G. If G is abelian, then center is equal to full of G. Okay. Next one is normalizer. Center means it is for the group. Normalizer means it is for a single element. If A is an element of G, then its normalizer n of A is defined to be set of all x in G which commutes with this A. Okay, elements which are commuting with A, with a particular element A are called normalizer, and the elements which are commuting with every other element of G are called what? Center. Right? This n of A is also a subgroup of G. Okay, next one, if G is a finite group, then number of elements in its conjugate class, CA means what? Conjugate class of A equal to order of G by order of n of A. Order of G means number of elements in the original group. Order of n of A means what? Number of elements in the normalizer of A. So that will give you the number of elements in the conjugate class. Right? Now let's see what is the class equation. The class equation is nothing but a way of representing the number of elements in the group. Okay, order of G is equal to summation order of G by order of n of A, right? Otherwise, this is nothing but number of elements in the conjugate classes, no? So order of G can be written as summation CA, where the summation varies from one element from each conjugate class. This can again be split into like this: order of G equal to order of Z of G plus, this is the center, no? So the elements which commute with all other elements of G, separate them as one part. The other part contains summation n of A not equal to G, order of G by order of n of A. So this is the class equation. So now we are going to see how to write class equation for permutation groups. See, in particular, when you have abelian group Z of G equal to G, no, in that case the class equation is very trivial. Order of G, that is equal to 1 plus 1 plus 1. How many times you have to write? How many elements are there in G? That many times you have to write 1 plus 1 plus 1 plus 1. Okay, right. Because in abelian group, how we have written? That is order of G equal to summation CA. These are the different forms. Summation CA is the class equation. No, CA means what? Conjugate class. When the group is abelian, two elements are conjugate if and only if they are equal. See, if it is an abelian group, no, B equal to x inverse AX you take. This is an abelian group. So AX I can rewrite it as XA. So what? B equal to A. So in an abelian group, the element is only conjugate to itself. So every conjugate class contains the element itself. No other elements will be there. So for all the elements, Modulus of CA, that is the number of elements in CA equal to 1. Therefore, the class equation equal to 1 plus 1 plus 1, 1 plus 1. How many times? Order of G times. That is, if order of G is 10, then the class equation is 1 plus 1 plus 1, 10 times. Okay. Now, this video is particular about what? The class equation for the symmetric group. So particularly here I am going to see about only symmetric group. Any two permutation in Sn having the same cycle decomposition or conjugate. Same cycle decomposition means if you write a permutation as a single cycle, then the other permutations which have single cycle representation, okay, they will be conjugate. If a permutation is written as product of two cycles, one of length 1, another one of length 3, then it will be conjugate to all permutations which have the same type of cycle decomposition, that is with product of one cycle and 3 cycle. Okay, so that is what we are saying. Any two permutation in Sn having the same cycle decomposition, they will be only conjugate. Okay, and another one in Sn, number of distinct n cycle. Distinct means what? Different forms of writing. Okay, different distinct n cycles is equal to n, and number of distinct r cycles where r is less than n is r into n minus r factorial. This I will tell you while doing the problem. So if in Sn distinct n cycle, the same number of n means n. If you want to write r cycles where r is less than n, it is r times n minus r factorial. Now let us find the class equation for Sn. Before that, the number of conjugate classes in Sn is equal to P of n. What is this P of n? Number of partitions of n. Partition means what? Different ways of writing the number n. P of 1 equal to 1, because 1 equal to 1 only, no. And P of 2 equal to 2, in how many different ways you can write? Either you can write 2 equal to 2 or 2 equal to 1 plus 1. So two different forms are there, no. So P of 2 equal to 2. Next 3. 3 can be written either 3 or 1 plus 2 or 1 plus 1 plus 1. So 3 different forms are there. So P of 3 equal to 3. Next P of 4 equal to 5, because 4 equal to 4, 1 plus 3 or 1 plus 1 plus 2 or 2 plus 2 or 1 plus 1 plus 1. So P of 4 equal to 5, and P of 5 7, P of 6 is 11, and so on, etc. So the number of conjugate classes in Sn is equal to P of n. So with all these things, let us compute class equation for S2, S3 and S4. First one for S2. We know that Sn is abelian for n less than or equal to 2. So S2 is an abelian group containing 2 elements. So its class equation is simply 1 plus 1. That's all. Next one, S3, non-abelian group, no. So let me tell you how to write the class equation. Now 3 is there, no. First you write the partitions of 3. 3, 2 plus 1, 1 plus 1 plus 1. Next let me write n of a, and then after that let me write CA. Then sum of the CA will give you the class equation. NA. NA means what? Normalizer. Normalizer means what? The elements which are commuting with the element A. So which will commute with A? Only which have the same cycle decomposition. See here, it's a 3 cycle. 3 cycle means only 3 cycle will commute with itself. So how many different 3 cycles are there? This is S3, no. So previously I have told you, no, in Sn number of distinct n cycles is equal to n. So here in S3 number of distinct 3 cycles is equal to 3. Okay, so next one, 2 plus 1 means 2 cycles and 1 cycle. So in S3, how many 2 cycles you can write? How many 2 cycles? 2 only. Okay, into 1 factorial. That is 3 minus 2 is there, no? So 2 into 1 factorial equal to 2. And then 1 plus 1 plus 1. So in how many different ways you can choose? What will you write? R into n minus r factorial? No, r is 1. So 1 into n minus r factorial. What is that? How will you write? See, the first already 3 elements are there. Each element you are going to write it separately. The first element can be chosen in 3 different ways. Second element can be chosen in 2 different ways. And the third element can be chosen in 1 different way. So 3 into 2 into 1 equal to what? 3 factorial. Okay, so this is how you have to write. Understand? Now we found out the values of n of a. Now let us write CA. CA is equal to what? Order of Sn by n modulus of n of a. So the order of Sn is 3 factorial. So 3 factorial by 3 equal to 2. Here 3 factorial by 2 equal to 3. 3 factorial by 3 factorial equal to 1. So totally, how will you write the class equation? 6 equal to 2 plus 3 plus 1. Okay. Next one, let us find the class equation for S4. In S4, how many elements will be there? 4 factorial. That is 24 elements will be there, right? Now let's write the partition for 4. 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 1. That means 4 cycle, product of 3 cycle and 1 cycle, product of 2 cycle, 2 cycles, product of 1 2 cycle, 1 cycle, 1 cycle, and product of 4 times product of 1 cycle. So these are the different partitions. Now for them n of a. So this is S4. In S4, how many distinct 4 cycles will be there? 4. And then for in S4, in how many different 3 cycles you have? See, 3 cycles can be written in 3 different ways. That is 1 2 3. Then how will you write? 1 2 3, 1 3 2, then 2 3 1, right? So 3 different ways into one cycle can be chosen in 1 factorial way. So 3 into 1 factorial. Already 3 elements are chosen. So the last one element can be chosen in one way. Next one, 2 plus 2. So this cycle, this 2 cycle can be chosen in 2 ways. And this can be chosen in 2 ways. Okay, so 2 into 2. And these 2 elements can be chosen in 2 factorial different ways. See, 1, 2, 3, 4. These are the 4 elements in S4, no? For choosing the first permutation, I can take either 1, 2 or 2, 1. Those 2 different combinations, that 2. And then this 2, if this is 1 2 2 1 means this will be what? 3 4 4 3. That 2 I have written here. And then why should I take 1 2 3 4 alone? I can take 1 3 3 1, isn't it? So that different combination will comes here. So for this two different ways, for this two different ways, and combinedly these two things can be chosen in 2 different ways. So 2 into 2 into 2, 8 different ways. I hope you understand this point. Okay, and then 2 plus 1 plus 1. See, this 2 can be differently chosen in 2 different ways. Into this 1 plus 1 is there, no? These two ones can be chosen in two factorial different ways. So 4. Next to 1 plus 1 plus 1, 4 different ones, no? 4 into 4 times, 4 different ways chosen in 3 different ways, 2 different ways, 1 different way. So 4 into 3 into 2 into 1 equal to 4 factorial. So these are the order of n of a. Next CA will be modulus of S4 by modulus of n of a, no? So 4 factorial by 4, 4 factorial by 3, 4 factorial by 8, etc. So what is the class equation? 6 plus 8 plus 3 plus 6 plus 1. Okay, next one, S5. For S5, number of elements is 120 and partition is what? How many partitions are there? 7 partitions. 5, 4 plus 1, 3 plus 1 plus 1, 3 plus 2, 2 plus triple 1, double 2 plus 1, 5 times 1. So this is nothing but 5 cycle, 4 cycle and 1 cycle, 3 cycle and 2 1 cycles, 3 cycle and 2 cycle, 2 cycle and 3 1 cycles, 2 cycles and 1 cycle, 5 1 cycles. This can be chosen in 5 different ways. This can be chosen in 4 different ways into 1 factorial, and this can be chosen in 3 into 2 ones when it is coming, no? 2 factorial. 3 into 2 means 2 factorial. Okay, this is 2 into 3 factorial. 3 different ones are there, no? 2 factorial. 2 into 2, 2 plus 2. Whenever you have 2 2's, it has to be 8 only. 2 into together 2 factorial. Okay, 8. Next here it is 5 factorial. So how will you write? 24, 30, 20, 20, 10, 15, 1. Okay, so that's all. I hope you understand this video. This is how we have to write the class equation for Sn. Thank you.